GATE 2022 session 1. So I hope many of you have seen this question. I'll give you just 1 minute. So anybody can just mention whether they have seen this question. Hello.
Yes, sir.
So can you guess this? Like any of you have seen this question?
No, sir.
Okay, let me read this question. This question is as follows: a 2-hour duration storm event. 2-hour duration storm event with a uniform excess rainfall of 3 centimeter occurred on a watershed. The ordinates of streamflow hydrograph resulting from this event are given in the table. So please note down, this is 2-hour duration storm event and has a rainfall excess of 3 centimeter. And this particular event resulted the streamflow hydrograph of these ordinates. So the question is that consider constant base flow of 10 meter cube per second and calculate the peak flow ordinate in meter cube per second of 1 hour unit hydrograph. Please note down, it is they asked to calculate 1 hour unit hydrograph. So in the question they have given 2 hour storm event and correspond all the hydrographs, but they have asked you calculate the 1 hour unit hydrograph. And this question is for 2 marks. So when this question is for 2 marks, so at least we need to do some computations to solve this question. So before proceeding further, I just wanted to ask you guys, like anybody has an idea how we can solve this question? Anybody willing voluntarily you can just respond. It need not to be exact, like you can respond. So a 2-hour duration storm event with a uniform excess rainfall of 3 centimeter on a watershed. The ordinates of streamflow hydrograph resulting from this event are given below. So the ordinates of streamflow hydrograph as given, and additionally they have mentioned that a constant base flow is consider, like we need to consider a constant base flow. So it has asked to calculate the peak flow ordinate in meter cube per second for 1 hour unit hydrograph. Okay, since nobody responded, let me explain briefly and graphically. So let's start with that. What they have given to us, let me draw. So this is a stream flow hydrograph. So this has given to us. So ordinates, all these ordinates they have given, like that all these ordinates are given. So from this they have asked to calculate 1 hour unit hydrograph. So to calculate this 1 hour unit hydrograph, we have to follow some steps. So this question we will solve by using S-curve method. So I'll tell you how we can solve graphically first. I'll give the intention what we are doing in this process. So this is a stream flow hydrograph. From this stream flow hydrograph, we need to detect the base flow. So suppose let's say assume this is a constant base flow. They have given 10 meter cube per second. So now by detecting the base flow from the stream flow hydrograph, we will get direct runoff hydrograph. Hmm, 2 hour duration. Okay. So as we know, this direct runoff hydrograph resulted from the excess rainfall of 3 centimeter. So to get a unit hydrograph of 2 hours, what we need to do is that we need to divide this direct runoff hydrograph with a 3 centimeter. This is to our unit hydrograph. So this will be the first step. So they have given the stream flow hydrograph. From this, we need to calculate the 2-hour unit hydrograph. From the 2-hour unit hydrograph, we need to generate the S hydrograph. So all these are D-hour unit hydrograph. In this case, 2-hour unit hydrographs. So I'll tell you what is S hydrograph and other things in due course of time. Just to see what we are doing here. So this is 2-hour S curve. So this is 2-hour S curve. From this, what we will do is that we will lag this S curve by 1 hour. No, nothing but T hours. Let's say this is A, this is B. From there, we will get 1 DRH of T hour with the intensity of T by D. So this is direct runoff hydrograph. From this, we can easily calculate the 1-hour unit hydrograph by dividing with the T by D. So this is an overall graphical procedure. So but let's see stepwise how we can solve. So am I clear? Like at least have you guys have followed a little? Please anybody respond like
Yes, sir, clear.
yeah. So this is a like step like this is a way we'll go. So for in this way we'll follow. So stepwise I'll show the things. So yeah. So I mentioned step one. So we need to construct 2-hour unit hydrograph from a stream flow hydrograph. On the right side of this slide, can you see this graph picture? So this picture is of stream flow measurement at the text source. So this I have taken from NT Cho book. This textbook is for advanced hydrology. So this particular graph shows the time variated discharge at a Milli Creek station. So you can see there is peaks on. So these peaks may resulted from some extreme rainfall event. So from this like stream flow, if we remove the base flow, we will get direct runoff hydrograph for that particular events. So essentially we do the same only here. So these are the ordinates. They have this is column 1 and 2 as given in the question. So for at the 0th hour, we have a 10 meter cube per second discharge. At 1 hour, we have a 16 meter cube per second discharge. At second hour, we have a 34 meter cube per second discharge. Similarly, at seventh hour, we have a 10 meter cube per second discharge. So now let's deduct the base flow to get the direct runoff hydrograph. See this base flow, why we are deducting the base flow? Because this base flow is is not from the current event. It may be contributed by from the groundwater. It may be from the previous event. So our intention is to calculate the unit hydrograph for this excess rainfall amount. So because of that, we will remove the base flow from this thing. So by removing the base flow, so 10 minus 10 will be 0. So 16 minus 10 will be 6. 16 minus 10 will be 6. 34 minus 10 will be 24. Similarly, all other steps. So here you can see 25 minus 10 will be 15. 16 minus 10 will be 6. 10 minus 10 is 6. So please note down, in the direct runoff hydrograph, the first ordinate and the last ordinate will be 0 only. And it will even continue for the unit hydrograph also. Even in the unit hydrograph, first ordinate and last ordinates must be 0. Okay, please note down, if these ordinates are not 0, then you might have made some mistake. Please check that. Okay, so column 4. So here I have written the formula, so how we got this. So column 4 will be column 2 minus column 3. So what is the column 2? It is a stream flow is a column 2 and the base flow is a column 3. So by deducting these elements element wise we'll get these values. So now to get a 2-hour unit hydrograph, we need to divide the column 4 with a 3 centimeter, because this is a direct runoff hydrograph which resulted from the 3 centimeter rainfall excess. I hope all of you know what is the definition of unit hydrograph. Unit hydrograph is a hydrograph which resulted from the uniform rainfall intensity over an entire catchment. Suppose let's say this is a d hour duration, and it has 1 by d hour uniform intensity and has excess rainfall of, please pardon me if my rating is very bad, 1 centimeter. So this particular unit hydrograph resulted from the excess rainfall of 1 centimeter with a uniform intensity of 1 by d hour. So to make it that 1 centimeter excess rainfall, we need to divide this column 4 with a 3 centimeter. So 6 by 3 will be 2, 24 by 3 will be 8, 30 by 3 will be 10.
So what is that 1 by D?
1 by
1 by D, sir?
1 by 3, not
1 by D. So 1 by D you have written uniform intensity.
So this will be uniform intensity
Of the rainfall?
Yes, of the rainfall. This is a definition of unit hydrograph.
Okay, sir.
Yeah. For suppose similarly, if you go for the T hour unit hydrograph, then it will have a 1 by T hour uniform intensity. Similarly, that. Okay. So this is a step 1. So in the step 1, we have calculated the 2-hour unit hydrograph. So what is the step 2? Step 2 is to generate the S curve. So before generating the S curve, let me mention what is S curve. So S curve, also known as SO hydrograph, it is a hydrograph produced by, please note down, continuous effective rainfall, nothing but excess rainfall, continuous excess rainfall at a constant rate, maybe 1 by T hour or 1 by D hour, like that. Okay, for a infinite period. So that is a one definition. Another and how we can get this S curve? So it is a curve obtained by summation of infinite series of d hour unit hydrographs spaced at dh apart. So here we can see how it can be generated. I have shown you here. Yeah, here I have shown you. This S curve can be generated by suppose this is a d hour unit radiograph. You lag another d hour unit radiograph and some. Similarly, you continue this process for infinite period. Here you can see for infinite period. Then you will attain to the constant discharge. So these are all like mathematical procedure to get a different duration hydrographs. So this is not possible in a real time situation. So these are the mathematical techniques to generate different duration hydrographs from the known hydrograph. Okay. So if you see this particular ordinate, this will be like u1 plus u2 plus u3. Like similarly, infinite. How many unit of we lag? In that way, we'll calculate it. So let's see how we can construct here. So from the previous step, we have generated the 2-hour unit graph. So please note down this column number. So in the previous slide, we ended with the column 5. I'm continuing with the same column 5. So I have taken the same value. So 0th hour is 0, first hour is 2, second hour is 8. Like that, I have taken the values directly. So see this column number 7. So what is the note? Please observe this point. S curve obtained by summation of infinite series of d hour unit graph spaced at dh apart. So in this case, let's say this is, let's say, 2-hour unit graph we already got from the previous step. Let's say I have lagged this unit graph 2 hour and perform this sum. So let's say this is 1, 2, 3, 4. Okay. So correspond, this will have 1, this will have another value, this will have another value, like that this will have na. So if you observe between 0 to 2, whatever the values are there, it will directly appear in the S curve. But from second, these values will get sum up. Can you note it down? So please observe, this is a critical point here. In this question, they have given ordinates at 1 hour interval, but the unit radiograph what we have is for 2 hour unit radiograph. This is a where we all make a mistakes. So many people, what they will do is that they'll simply lag these 2 times and add all the points. That is not correct. Please note down. So I'll critically observe. So what I'll do is that I'll take these first 2 ordinates, directly put it in column 7. So now these 2 ordinates I'll shift it together. I'll shift it together and place it here in column number 6. This column is nothing called as S curve addition. So now sum these 2 and place here. 8 plus 0 8, 10 plus 2 is 12. Now you take these 2 together and place it here. So now it will be 7 plus 8 15 and 5 plus 12 17. And again you take these 2 and place it together here, and it will be 2 plus 15 is 17 and 0 plus. So you continue this process until you reach the constant discharge. If you see all these like 17 are constant discharge. In this way you will generate S curve. So I'll pause here. If anybody have a doubts, I'll clarify here. I hope I'm clear. Okay, let me move forward. So this is a step 2. Now this is a final step. So now we have the S curve, and from S curve, how we can generate the T hour unit graph. So that is the same procedure I have demonstrated earlier. So consider 2 D hour S curves A and B. Here in this case, 2 hour means 2 hour A and B displaced by T hour. In our case, we need 1 hour unit graph. So it will be T will be 1. So if the ordinates of B So consider two hour S curves A and B displaced by T hour. So you look at this figure, right side figure. This figure I have taken from Subramanya book. So consider two S curves A and B. So now lag these two curve by a T hour. So now you have lagged these two, and these two curves have a constant intensity of 1 by d centimeter per hour. Okay, and observe this thing, and this is T hour and has excess rainfall of 1 centimeter. Okay, now if the ordinates of B are subtracted from that of A, the resulting curve is the direct runoff hydrograph produced by a rainfall excess of duration TH with a magnitude of 1 by D into T centimeter. So suppose if we deduct this ordinates at this point and at this point, and this SA difference of SA minus SB is nothing but a DRH of excess rainfall of T by D centimeters. So this is a statement. So now from this DRH we need to calculate the here T is 1 hour in our case. So from this DRH we need to calculate the 1 hour unit graph. So how you will get, and we will simply divide this DRH with the T by D excess rainfall depth. So we will get the T hour unit graph. Okay, this is the procedure we can see. So observe the column numbers again. So I have in the previous step I have stopped at column number 7. So I will start with the same column number 7. So time same 0, 1, 2, 3, 4, 5, 7, 6. So here I have added extra two columns because here we are lagging this curve by curve now. So as a safer side I have added, but though you added, but these ordinates will be 0, 0 only. There is no issue. So this is S curve we obtained in the previous step. So 0, 2, 8, 12, 15, 17 and all. So now lag this S curve by 1 hour because we have asked you calculate what is a peak coordinate of 1 hour unit hydrograph. So now for that we have lagged by 1 hour. Suppose if we ask peak coordinate of 3 hour, then we will lag 3. If we ask 2 hour, then we'll do the same in the similar manner. So we have lagged by 1 hour. So now this ordinance will go here. So now what we will do, we will deduct column number 7. So we will deduct column number 8 from the column number 7. So 0 minus something is like dash is 0 only. 2 minus 0, 2. 8 minus 2 is 6. 12 minus 8, 4. Similarly other things. Okay. So this particular is the DRH of 0.5 centimeter excess rainfall. So now we need to calculate the 1 hour unit graph. So how you will get the 1 hour unit graph? So this is a column number 9. Sorry, this is my mistake. This is a column number 9. So this is column number 10. So divide the column number 9 with the 0.5 centimeter. So by doing that, so it will be like 0.5. We will get the ordinates. So if you observe, what is the peak coordinate here? 12. So this they have asked to calculate. So this is the overall summary. So first you will calculate the stream flow. First you will calculate the direct runoff hydrograph from the stream flow by detecting the base flow. From the direct runoff hydrograph, you will get the 2 hour unit hydrograph by dividing the excess rainfall depth. From this you will get the S curve, and you will lag S curve by T hour, nothing but 1 hour here. So and from that you will get a DRH of 0.5 centimeter of 1 hour duration. Please note, observe carefully, like when I say 1 hour, 2 hour, it has to be proper. Then only we won't make any mistakes. From the DRH of 0.5 centimeter excess rainfall of 1 hour duration, we will get the 1 hour unit hydrograph by dividing this column number 9 by 0.9. So this is a overall step. So I'll tell you the shortcut. With, this is a very long procedure because and it is worth for 2 marks. Yeah, worth for 2 marks. But I'll tell you the shortcut also how you can proceed. Let me see how many are there. So yeah, before proceeding, like I'll before telling the screen this thing shortcut, I just wanted to know, understand how many of you understood the question. I know this is a very long procedure, but it is worth to know, like because you can expect the question from intergraph every year, whether be it a 1 mark question or be it a 2 marks question. Every year in all the gate papers, you can expect at least one question from the intergraphs. So it is necessary to know the detailed procedure. Okay. Yeah. So anybody wants to add anything here? Okay. Let me tell you the shortcut. So if you observe here, what they have asked, they have given 2 hour storm event and they have given the 2 hour stream flow hydrograph, but they have asked you to calculate the peak flow ordinate of 1 hour hydrograph. See, if you observe the column number 5, this is a 2 hour unit hydrograph which we have calculated by you deducting the stream flow. And observe this carefully. You subtract ordinates of 2 hour unit hydrograph only. I mean, hmm, I mean 0 minus 2. How much is the difference? 2. 2 minus 8. How much is the difference? 6. 10 minus 8. How much is the difference? These things. Similarly, other steps. So observe what is the maximum difference you got here? 6. And what they have given the 2 hour unit hydrograph, but they have asked you to calculate the 1 hour unit hydrograph, isn't it? So what you can do? So how you can do is that you can divide this 6 by 1 by 2 equal to 12. This works for the peak flow ordinate. This works for the peak flow ordinate. This will be shortcut. So what you will do? Sorry. You will look at the difference of the ordinates and pick the maximum difference and divide with this thing. Suppose here is 6, here is a 6, and this is they have asked t by d directly. So 6 by t by d you will get. Suppose here they have asked you to calculate 4, then what will be 4 by 2? So answer will be 3 meter cube per second. This will be peak flow ordinate. Understood? I hope it is clear. I hope I'm clear.
Yes, sir, it was clear.
Yeah. So did you understood the shortcuts? It will work for the peak flows.
Yes, sir, it was interesting, sir.
Yeah. So we just look at the difference between the ordinates, pick the maximum one, and
Yes, sir.
divide with that 1 by 2 or 4 by 2, whatever it is. Hmm?